Okay, just for today, I added some animation to the presentation. I don't know if you will notice it, but Francesco don't knows about it, so it will be fun.
Cool. Welcome everyone, Speck&Tech number 18. Woo! I don't know if anybody was counting the number of people that we are here, but actually we're over 100. 1, 2, 20. Oh, okay. So we are basically
50 people.
Yeah,
yes.
Yeah, nice. Illegally. Okay, cool. Yeah. We are 99 people according to the yeah.
Tiziano, stay awake, please. If there are emergency, we count on you. Yeah.
All right, let's start. Number 18. Before starting, we have our friends from Open Data Hack about saying a couple of seconds of words where they are. Nobody here. Nobody here.
Yeah, we tried.
We tried, so yeah. Anyway, it's a nice initiative. Just look for them. There's this website. They're launching this hackathon on developing chatbots in the area. That is their website. Probably you will run on our channels. They're not here, unfortunately, but we didn't know. But probably more space for us.
Yeah.
So, whoa, what the fuck is this?
Yes.
Okay, Speck&Tech number 18. First. We have two speakers tonight. Our friend here, where is he? MATTIA. Cool. A big applause for him. And welcome. And the second one, Valerio. Over there. But just before starting, we have a couple of seconds where we say thank you to everyone that's helping us. And we really deserve it, and they deserve that. Because I mean, we grow up so big, and this is just the first event of 2018. I don't imagine the rest of the year, but it's going to be awesome, definitely. We have a couple of events that we already planned. We already have scheduled March, we have already April, May, June, and a big event on September. You will know for sure about it, so follow us on our channels and you will know more about it. First of all, a big thank you to Data Group. They were one of our biggest supporters for our hackathon that we ran a couple of months ago. And actually they just launched a new digital academy. They're looking for professionals, so people that just graduated, 6 months training, then 15 days of working, and then try to hire them in their company. They, just to tell you, they're big. They're big. They're big. They do like millions and millions and hundreds of millions of cash every single year, so they're big.
Which is a lot of spec.
Yeah.
All right, for the other sponsor that we have, as usual, we have Impacta, which is this co-working space. Basically, if you need a co-working space in Trento, this is the place to be because there are another. So yeah. And the other one, yeah, Pretty Red. It's my company. We do basically design and development of digital products. Moreover, we have other ads at the beginning.
Yeah, which is my organization, Yeti Digital. We are based in Povo, basically in the same building as FBK. If you're interested, we are doing an innovation talk on the 5th of February where we're going to have the CEO of Spaziodati, one of the coolest companies here in the area, that's going to talk about his entrepreneurial journey on big data. They're doing big data visualization, a number of cool things with data. So if you're interested in how to turn just a bunch of data into a company, just come and we have also a pizza for free. So yeah, I think you should definitely do it. Anyway, our supporters, our sponsor, GitHub, Cloudflare, Fatura and Cloud, Diginate, they provided the cool stickers that you can see at the entrance of the room. We had a number of iterations. First one with our famous logo, second one with our t-shirt, and then the third one, the stamp of saying I'm a Speck&Techer. So just go there and you get to get them at the donations table. And of course, Segata. How many of you don't know Segata?
Yeah, we increased brand awareness of Segata between nerds of like full coverage.
So is the marketing people? Segata, yeah, we're here. Okay, anyway. They're cool, they're based in Sopramonte, but they also have a hub in Gardolo where we go every single time to get the spec at 6 p.m. just for this event. So remember it. They have a lot of stuff, also cool burgers and stuff where you can bring for doing your barbecues. So just check them out. Check it out. Check it out. Yeah, check it out. Speck&Tech, our website, you can go on speck&tech and you can see all the previous issues, all the slides. A number of people were like, ooh, that speaker was so cool, I would like to get in touch with them. And you can see there, you can see also their LinkedIn, also their private pictures sometimes. And also just go on our Facebook page and you can definitely like us and follow our channels on the Telegram. We are more than 400 something over there, so you definitely know if there's something happening around, not just Speck&Tech events, but also conferences, hackathons, and cool stuff.
Yeah, and that's for the broadcasting part. If you want to interact with other people in Speck&Tech group and you don't know how to talk to people, well, you can write to them. We are currently on Slack. How many of you doesn't know what Slack it is?
Everyone knows Slack.
Really? All right.
Okay, cool. Thanks, guys. Courageous.
And yeah, if you want to talk about stuff with other people that are in the Speck&Tech group, we are usually online because during working hours we just surf the web and look at Slack of Speck&Tech, so it's a cool place to hang out. If you don't like it, please let us know because we are using for our internal organization, but if it's not useful, we can just use something else. Just feel free to write us.
Yeah. Question that everybody asks, do you have to donate? And we say, no, you don't. But I mean, yeah, you're more than welcome to donate because it's actually how we sustain the association. We run basically on zero budget. Everything that gets into from one night, we reinvest it for the next night. So all the beers on the spec, everything that gets here, it's basically because it's the money that you give us for the upcoming night. Especially if you donate, we also give out 3 licenses for JetBrains at the end of the night. So if one of the nice donators, you can definitely get one of these. And we reinvested in the beautiful Speck, and yeah.
I don't know if it's an investment. But
yeah, it's gonna come. It's just waiting for us in the kitchen. So yeah. And then for the beautiful beers, and you know, this time we always were buying random beers from our friend of Baby Cosmo. This time we wanted to do something better, just upgrade our events. We said this community is big. We have been here for 2 years. We deserve better beer. What do you think about? No. No? Is it worth?
Yeah, not so much.
Yeah, okay. Anyway, this is Villa del Bosco. They're cool. They decided to really partner with us, and they discounted a lot our beers. But still, like you know, we were buying beers for 80 cents before.
Yeah, those are actual prices.
Yeah.
Like this is what we were paying for beers, but now.
And now we were paying.
Man.
Yeah. So you know, like this beer was probably like around €4 for the bottle, and now we are cutting half because they're nice. But it's still like almost double the price than the beer. So what we're trying to do tonight is that we want to see if people like it, if you like the beers, if you think it's worth paying a bit extra for getting better beers. Otherwise, we will just go back and say...
Yeah, basically you can express your opinion with money,
yeah.
Which is like real life. Yeah, as Pietro is saying, because we can talk to him telepathically.
A big applause to Pietro!
Yeah. Yeah, probably not many of you knows about Pietro. Pietro is one of the biggest contributors in Speck&Tech, but he's like, you know, vice president going behind the scenes and controlling everything.
No, anyway, what Peter was telling me is that there are a couple of seats here and there. So instead of just standing there or just...
Yeah, like there's one here.
There's one here, there's one there. Maybe the people that are sitting next to an empty chair, just to raise your hands so people can... Yeah, look at that.
Empty places, if you need them. Yeah.
Okay, there's one here as well. Okay, nice. Yeah, oh wow, get back, I don't know why. Anyway, it was, yeah. I think you know already, so we paid a lot for these beers. Let us know with your cash if it's worth, otherwise we just backtrack and we go back to the previous beers. So do you have to donate? No, but you can buy a t-shirt. So these are beautiful, you can give it to your grandmother, to your friends, to your like...
If you buy enough, Francesco will stop asking.
On the 14th of January, there's St. Valentine, you know, for your girlfriend or something like that. It's so nice.
Next Christmas.
No? Okay. Anyway. Okay, guys, we were bullshitting a lot. Sorry about that. We're actually running out of spec and energy and stuff, so we need to call the first speaker.
Big applause!
MATTIA ZENI. Okay, so considering everything that happened tonight, we planned to start at 8:45 for the first time, and it didn't work because our projector fucked up a couple of seconds ago. So we were kind of able to pull it up this way. I don't know if all the people managed to see it, to see within the room, but Julia is still setting up the slides. Sorry about the delay. In the meantime, you just help me sing in, saying hey, nice. No? Okay.
No, io sempre tipo
Okay, thanks for the experiment, it was nice. We're to our speaker, MATTIA ZENI.
by saying that this presentation is not about some new cool machine learning technique, but on the other hand is about how to use techniques that are already there to do something that is really cool. So actually this is my PhD thesis, so I cut some parts so that I can present it to you in a better way. So the title is this one, Rigid Sensor Data Streams and Human Knowledge. So to let you understand what this is about, I have to do a motivating example. So let's say there is one guy that has an event. So he has to do something. He has to attend, for example, an appointment for lunch. This appointment is in some place, of course, so in a restaurant, in the city center, for example. And he has to attend this event with someone, like a friend. So what can be the role of technology, of a smartphone, of an artificial intelligence in this situation? Well, we have this piece of technology, like a smartphone. Let's say we manually put an event in the agenda, or, okay, there are some smarter ways of doing this, like applications that read emails and put automatic events in the agenda, but, okay, the standard way we do it is doing it manually. Yeah, and then what do you want back from the technology? For example, you want to be alerted when to leave for this event so that you won't be late, because you cannot afford to be late this time. And let's say the actuator in this case is the notification, the notification on your smartphone. Fine, this is great, and this is how it works today, more or less. But let's consider a more complicated example, which actually is what happens in the real life. So there are external factors that affect, in this case, the time that that's required to reach this restaurant, like weather conditions. There are unexpected events, so I have to go by car, but my car, I have no fuel, the gas tank is empty, so I have to stop and refuel, and this takes time. Then there are other, let's say, personality traits. So this guy, which we call Fausto, is always late. So he's always late, but this time cannot afford to be. So we need to consider also this. And finally, there can be anything else. So for example, a personal goal. So I don't know. I want to do 10,000 steps every day because I want to be fit. So all these are situations that arise every day and that we must take into consideration. But of course we cannot, because we cannot just always, every time we have to do something, look at the weather, remember everything about anything that can happen, and so on and so forth. So what should the role of technology be in this case? We always have this guy here, the smartphone, which must be aware of, we call it the user state of affairs, the user context. So this smartphone has to know what, who we are, what we are, what we are doing, and so on and so forth. All the possible things that can happen to our lives. The final goal is that knowing this information, the AI, the smartphone, the machine, whatever you want to call it, needs to adapt and to personalize its output on ourselves. That's what we want. And in this case, the output is a personalized service. So instead of having this fixed time interval, 30 minutes before I leave, the time interval can be automatically defined by the machine, considering all the previous elements I told before. So this is a nice example and a nice situation, but we are not there yet. This is not possible today. So why? Because these machines have no knowledge of the user. Of course, at some point they have, so Google knows where we live, if we tell him, knows where we work, and so on and so forth. But we need the complete package, so we need to know the complete user context, and by context I mean the locations of the user, the activities the user performs, and who's the user with. A machine should be aware of this information. So, what's the problem? Why the machine is not there? Why the machines cannot know the user context? So, there are many reasons. The most important one is that there is a gap. There are two different representations. So here we are dealing with two different, let's say, types of data. So there is the human, which of course is intelligent, hopefully. So the human understands what he sees, what he perceives, mainly thanks to his, her intelligence, habits, and routines. So I know that to go from here to Pogo, it takes me, I don't know, 7 minutes by car, 15 by train, and so on and so forth. So these are my habits and routines. I understand this. On the other hand, the machine has no intelligence. The machine is a piece of technology that can handle huge amounts of information in a very short period of time, but it's not intelligent. So here in the middle there is a gap. So this is called the semantic gap, and this is why the machine is not able to perform as in the second example I showed you before. We need something in the middle to fill this gap so that the machine can understand the human context and then can elaborate and process all the huge amount of information it can have, so that it can provide services to the user and improve his quality of life in the end. So let me make an example about this, which is the location. So let's say there is this a localization service, so there is an application or something else that needs to report where the user is. So if you ask this application, it should tell, okay, Mattia is here or there. So going back to this level, so the two representations. So the machine represents a location, a position, as you see here, so coordinates, latitude and longitude, for example. So I'm sure you don't know where this place is. Maybe you know, yeah, okay, this is Trento because it's 46 and 11, so this is Pogo specifically. But again, so the machine cannot provide this data as an answer to the user because the user won't understand it. So it needs to do something more to provide an answer that the user can understand, and this is where the gap is. So an example can be, we do a lookup, so there are plenty of services. We can understand that these coordinates refer to a building. Fine, I can reply, okay, Mattia is in a building, but it's not really useful. Then we can do something smarter. Okay, we can say, fine, that building is a university because someone told the machine, created some kind of structure in the data so that we know that that building is a university. So here you see there are more information. So if I give this answer to my girlfriend, she knows I'm at work. If I give this answer to a random guy, he really doesn't understand if I'm there because I study, I work, or whatever I do there. But then of course the machine can also do wrong lookup. So instead of telling me I'm in a building, yeah, I'm in a building, but it can tell I'm in a toilet, or I'm in the forest behind the university. And okay, these answers are correct, but are wrong. I cannot communicate to someone that is in the toilet at the moment. So why is this? Because there is no, let's say, single way to map sensor data to knowledge. So those information here basically are what we call knowledge. So I guess you know how localization works. So you have 1 point plus certain accuracy, if the accuracy, which is this radius here, if it's low, is good, if it's high, is bad. So actually it can be bad in both ways, because I can say, okay, I'm in a university, but maybe the machine is so accurate that it understands that I'm in a toilet, but this information really cannot be provided to someone. So, on the other hand, how can the human solve the same problem? So, if let's say I'm in a conference at the other side of the world, and one guy asks me, where do you work? Well, I cannot reply I work in a university, because it's a conference, so for sure I work for a university. But then I cannot say I work in Via Sommarile 4, because they don't know what I'm talking about. So even at the knowledge level, there are different ways that I can use to provide the answer. And those ways depend on the context, because in that specific situation, I have to provide this answer. I work for the University of Trento, even if these two were fine as well. On the other hand, for example, if a colleague of mine asks me, where are you? I have to reply in one of these ways, for example. These are just examples. I cannot reply, I'm in the University of Trento because he knows, he already saw me today. So, this is the problem. There is this gap, this different kind of information, and this is how we try to solve it, hopefully. So, we define a methodology that leverages on different, let's say, fields of study. So, the first one is the semantic web. So, these guys that work with ontologies, knowledge, and so on and so forth. Machine learning, of course, otherwise I won't be here. So, as I said, the machine has these huge amounts of information needs to be processed in a way so that the results are meaningful for the user. And for this, we use machine learning, of course. But then we need also to understand how we have to deal with the user, and this is part of sociology in general. So our research in my group is about all these three merged together, and this is where, let's say, we are novel, where the cool stuff is. So, let me start with the semantic web. So, what's semantics? Again, are these guys that work with concept, languages, and try to create structures out of them. So, for this, we use ontologies. I have an example now that can be used to model the user of the world. So, there is this ontology, this knowledge graph, this database, in which there is me, which I'm a person, so I don't know, I work there in that location, I'm here now in this building with you, and so on and so forth. So there is a network created that considers the user, which is the core of the system, and all the stuff that is important to him. So, okay, why ontologies? Because they are general, they are compositional, so we can add stuff. Once we know what a person is, I can add multiple persons. So, I'm a person, you are a person too, people too. So I can add all of them inside this graph. Once you're there, the system can play with this data. This is an example. I'm sure you know about this. But then, the cool stuff is when machine learning kicks in. So we need to process the data, and in the end we want to create this stuff. So we want to populate the knowledge graph. The knowledge graph is something the user understands because it's represented as the user wants. And the core is to analyze the data, and in particular, thanks to the ontology, we can split the huge problem, understanding what the user is doing in many more complex tasks. And these tasks are modular. For example, in my profile, so in the knowledge graph, there is me, I'm standing, I have this thing in my hand, and so on and so forth. All these elements are created, let's say, understood, using a microtask, which is, in the end, a machine learning algorithm. So each machine learning algorithm takes information from sensors, in particular the smartphone, takes information from this knowledge graph so that it can disambiguate in specific situation when it doesn't know what the output is, and in the end the output is put back in the knowledge graph. And this process and the compositionality is the key of the solution. So let's say each property, each element can be solved using different machine learning techniques. So we can use random forest, DB-scan, and so on and so forth, all of them. So this was an example. They asked me to put something more technical. So this is an example of our infrastructure. Basically, you have data level, and each task takes one machine learning technique to understand each element of the user context. So where the user is, who is he with, what is he doing, and so on and so forth. And all these elements are used to populate this graph, which contains all the information. But as I said, the core of all this is the user, because we need data from the user, because we want to understand what the user is doing, because we want to improve his quality of life. We want to provide services to him that are useful. So the user is the key. is the main source of the information. We want him to collaborate because, of course, he has to participate in this. We are not like Google. We do not want your data for our own purposes. This data is collected for you, for us. To do so, we need to understand the human behavior because we need to understand, for example, when to ask the user feedback. It's not an easy task. And for that, we had to work with sociology experts. And this was really tough. And then, for example, one amazing tool we found very useful from the sociology part of this research are these time diaries. So basically, sociology use them are this paper where people provide answer. So there are questions and people provide answer on let's say about their days. So we digitalize them and we put inside our application. So this is not only theoretical stuff. We have a system that is working in the university and that can do this. Of course, it's composed by different systems. We have to acquire lots of data. So we are really talking about huge amounts of data, big data. But then we have to implement what I told you before. So this combination of machine learning and this knowledge information. And then, of course, we have to use this knowledge so that we can provide services back to the users. That's the key. So let me go very fast through this. So, of course, we have, as I said, we have two types of data. So we have a lot of sensor data from the smartphone. We have a pipeline for storing, collecting, whatever on this data. And of course, we need a huge database here. I'll talk to you about this in a moment. But then we have also the knowledge part, which has different challenges. For example, we have schema matching, disambiguation, all the knowledge, the typical stuff you do on knowledge. So you have to disambiguate, to link entities, and so on and so forth. And that requires a different database, for example, database technology. But then there are these machine learning tasks, which of course need a data scientist to be defined, because not all the people can do that. Then we need a repository, we need to instantiate these tasks so that they can, from that moment on, they can start producing results from the user. Of course, they need access to databases and the user feedback. Finally, we have the knowledge, how you provide services. So you have to exploit this knowledge you generated. For example, you understood from 2 days of data that the user goes to sleep every time at, I don't know, 11. So the knowledge exploitation, for example, is a service that understands this and uses this information to, I don't know, turn off the ring of the smartphone. I don't know, something like this. Of course, since you are using the data and the data are going out of the system, you need privacy. Of course, privacy is a big issue, but we addressed it. The data is stored all anonymously, and then you can provide these services. So the system, so this is the name of the system, stream-based system. So as I said, we have to deal with huge amount of information, so we need performances, because we don't know how many users we are going to have at any moment in time, so we need great performances. But then we need modularity, so we have to find solutions so that we can instantiate and at the same time turn off, basically, the different machine learning tasks, for example. Then, of course, we need scalability, high availability. The system must be online forever. And one important element is fast deployment. So we need to be able to run the system very quickly without wasting time if we need to do a new experiment, for example. I showed you the experiment in a moment. Of course, to achieve this, we use state-of-the-art software technology, so Docker, Kubernetes, I guess you already heard about this, Cassandra, which is the main database. Actually, the core is is Cassandra. So at the moment we have this instance with 5 machines with 5 terabytes of data, but the idea is that it can scale linearly with the number of machines. But then, since we are dealing with machine learning, we need also a lot of performances, and for that we use Apache Spark, for example. Just some example of the technologies we use in our current implementation. As I said before, the core is data, as always. So we developed this application, which is called ILO. You install it on your device, and it collects data continuously. Actually, at the moment we are at 39 streams of data, and it can generate 1 gigabyte per day per user. These data are, let's say, at the machine level, with respect to what I said before, but again, we need the other level, the machine interpretation of what's happening, and that's done through this time diary. So periodically the system provides you with a notification that asks you a question. But then, of course, everything needs to be configurable and adaptable. So if, I don't know, the user wants this smart alarm system that wakes you up in the morning in a beautiful way, probably we don't need to collect his location. So here with configurability and adaptability, I mean, we can decide what to collect and when to do it, and how frequently to do it. And then, of course, the services can be provided through this application. So, again, in terms of notifications, visualization, and so on and so forth. So, this is real stuff. We used it in some use cases that are currently out there. So, we work with the municipality of Trento within this European project, Crowd. So, basically, the idea was to help the municipality, the decision makers, to apply new policies for the city in, let's say, in a smarter way, in a more aware way. So, for example, they wanted to understand the modal split of the people. So, what's the modal split? How you move around the city. For example, that you take the car till Zuffo, and then you take the bus to the city center. Of course, once they know this, this can have positive consequences on the society, because they can, for example, understand that the bus to Povo is crowded every day, hopefully. So they do something for this. So everything started by this law. There is a European law that forces municipalities to reduce car usage in the cities by 1% every year. So they started asking, how can we do that? And that's why they did the model split thing. For example, some decisions they want to do is, should we move parking lots outside the city or not? Should we improve public transportation? Should we vary parking fees? So I guess every one of you asked why the parkings in the city center are more expensive, because they don't want car in the city center. I didn't know this. So we created this dashboard on top of the data we collected. For example, here we show, we run some machine learning techniques to understand how people move to the city of Trento. This actually is by train. And if you see, actually, so this is the Brennero railway, and this is Valsugana. So actually, it works for real. So then we did an experiment with the university. The group, so the two guys are there, they asked me to put this slide, so so we did already an experiment last year. Basically, the idea was, can we understand how students' time allocation affects their academic performances? Which means, if you stay on Facebook while you study, is it good or not for your academic performances? Of course it's not, but now we have the proof. So we did this experiment on 72 participants for 2 weeks last year, and we had this amount of data, which can seem, okay, reasonable, but actually, so this is not photo, this is not video, this is strings. So these are strings, so it's almost 20 billion value pairs. So the idea is, can we create this quantified self report? Can we create quantified self reports to show to the students so that they can actually understand how their academic performances are going, if they can change something to do better? So we discovered that scientific faculty students that use social networks while they study, their academic performances go down if they do this. But I'm talking about male students, because if you consider female students from humanities faculty, the thing is different. They are more affected by instant messaging, on the other hand. So they can just look social networks whenever they want. No, it's not real. I mean, these results are real, but this is the most, the application that most, that affects at most the academic performances. So these are some graphics we draw to actually do this paper, to create this paper. So basically this is hours of the day, days of the week, and so this is the number of sessions of social media applications. So the darker, the more sessions, which means you open Facebook, then you open again, and you open again. On the other hand, these other two means how long you stay on Facebook in a single shot, let's say, a single application usage. So these are some of the results we created using machine learning techniques out of the data. Another interesting experiment was, so the thing was, can we understand what the quality of our data? Because of course the users were providing annotations, but we don't know if they are correct or not. Actually they are not really. So we thought about this. So we know that a student has one home, probably two, probably three if he's not very rich. And then we tried to plot how many times, in how many locations the user said to be at home. So this guy said he was at home in 14 different locations in Trento. So either he's very rich or was cheating. And in general, I mean, so the average is this line here, 3.47, which is kind of high. I mean, we were expecting 1 or 2, which is, I mean, the two over here, which are the highest, by the way. But then, of course, there is something wrong. So we decided to study how the users were replying. So was one guy, so the question was there, so was the guy replying in 1 second, so just click and just even don't looking at the possible answers and just replying. So filtering out this behavior, so the amount of time required to answer and actually the delay between when the answer was popped up to when he answered, we were able to improve the results. So in this case, we have 2.81 homes, and in this case 2.38, which is almost perfect. Again, this is another analysis we did. So can we evaluate the general quality of the all data, not only home? So we did a lot of study actually, and we come up with this strategy about the consistency. So we evaluated the entropy of each location. So in this place here, how many times the user replied differently. So if the guy said this is a pizzeria, this is a university, this is a, I don't know, police station, something is wrong. So this graph shows actually this, the consistency from 0 to 100, the higher the better, and these are the different students. So you see that on average, at 70-something%, the users were replying correctly, at least for locations. So we have, so this is only one experiment, one data collection, 2 weeks. Now we have other experiments scheduled already, so there are in February and March within the Crowd project, and we have another one with students again in March, hopefully. So if you have students that you want to participate, ask us. And then another in April. So the number of people is increasing. So in this one, we hope to have 1,000 people for the municipality of Trento for 6 months, which is a lot of data. So, if you are a student and you want a thesis, ask me. So we have everything. So can be software developer in backend, in frontend, Android, iOS, And we have a lot of machine learning. Now we are collaborating with professor of machine learning at the Povo, and we have huge amounts of theses, and I guess that's everything. That's all.
Thank you very much for the slides and everything, the presentation. This is very interesting, and I never thought that doing Facebook in my professional life would affect my performances, and I never did it, in fact. So now,
questions.
Yes, as usual, if you have any questions regarding the presentation, like how many Facebook checks by day is optimal to my life, or
Questions?
now is the time. Raise your hand.
Everything clear?
Otherwise,
Everybody?
Francesco makes questions, which is very awkward. Please
Yeah.
don't.
Sure. Nobody, everything was super clear? Okay, here it is.
What are you user of the application volunteers?
Yes. No, so yeah, they were volunteers. They got compensation. It was like €7. Plus, we had 3 final prizes. It was 100 and something euros. So, so for this specific case, the sociologists had specific requirements. In particular, they wanted people from the first year of the bachelor that had previously filled the paper-based questionnaire. So we had some constraints. But in the second experiment, we don't have constraints. Anyone can participate.
My question was because I was surprised about the amount of people that answered wrong to the question.
Yeah, we didn't force anyone to do it. Yeah, so consider that one answer was for 30 minutes, so there was a lot of noise in the sensors. I mean, because usually you collect 1 label per second or even less. So, I mean, here we have to accommodate everything. So if you want high precision, we'll lose all the users because no one will keep doing it every second. So, yeah.
What kind of question did you ask to the user?
So there were 3 questions: where are you? What are you doing? Who are you with? Very general. There were like 13 possible answers, like home, university, pizzeria. Okay, thank you.
Any more questions? We've got time, people. Night is long. Yeah, look at that.
Okay, parla forte.
No, it's fine.
Yeah,
I managed to, don't worry.
So how do you think your model is robust enough to provide answers for more situations? Like you said, you predefined some set of answers, and let's say it's some much more huge context that may have like hundreds of answers.
I don't know. So the idea is we don't really want to understand everything. We want to understand what the user believes is important. So the idea is that the machine will learn what is important for the user. So yes, in this case there were closed answers, so just a list. But the idea is that the user will be able to reply using any label, being part of WordNet basically, so this huge list of words. And then, yeah, the machine can adapt to any label, and eventually will be able to learn these elements. So it's the user in the end that defines which labels are important.
All right, one more question. You shown that you have like a knowledge graph that you populate, basically with that same data. Very generally, do you maintain some kind of event state or something like that? Event state, yeah. I mean, like you have this time diaries, right? So the answers depending on the date or consequences, the previous answers are basically different state.
So if I understood correctly, so the knowledge graph keeps updating. So if I tell the machine I live here, of course the information can change in time. So, for example, if I keep giving the label home in a different location, eventually the machine will understand that something is wrong. So the knowledge graph, yeah, can keep different. So is that what you're asking? Yeah, so can keep different, let's say a version in different different versions in time.
Yeah, that's what I mean to understand.
Another question?
Just by curiosity, like, do you plan to? I mean, since you told us that you research about transportation, my question is, do you plan to share the data with the municipality in order to change something? Because, like, from my perspective, like, train of Valsugana, it's like the slowest thing on earth. Probably I'm not the only one. And no, I mean, do you plan to share this? Is there any plan to change stuff actually with the stuff, or is it like very hard? Like, probably.
So the cloud project, the one we are working in, actually, so the municipality wants to change the thing, change how things work. So they precisely asked specific questions to us, so like the model split or other stuff. We are building a dashboard for them so that the decision makers will eventually see these problems and hopefully solve them. That's up to them.
Cool, thank you. Big applause for our speaker. Okay, great. Now we do a great activity. We play Tetris. So everybody's like moving around and trying to get there to grab a beer or go to the toilet or go out.
Not breaking stuff.
Yeah, maybe we can open the door over there. 5-minute break before our second speaker, like 5 minutes, not 15. Grab something, take a nap, and then come back.
Comunque lo specchio è desaparecido. Volevo quasi chiedergli che tecnica deve scendere che però ha detto sembra che aveva detto io vado a tirare fuori. Ehi!
dietro tutti i coglioni.
Beh, guarda, da quanto ho detto, noi due ancora pezzi 10 anni fa volevamo fare un videogioco. Vedete che il gioco lei vuole fare un gioco volevamo fare quello. Abbiamo fatto, ho cercato gente, negativo la gente delle bimbe, ho fatto il tecnologo scout, il grafico, basta, è una cosa, abbiamo passato delle ore. Ciao! Dai, la foglia è andata in casa. Quale parte?
Non so come la prima volta sì.
Non so, è un po' strappo corregge come ma no, anche i topic potrebbe far vedere un po' più. Non è più difficile l'esame di sé se correggessi in maniera ma del correggere è un sì o no ho visto solo che ci fanno casino di testa se ci metti un paio d'ore hai 2 ore perché noi non siamo americani abbiamo un caso ho visto però quando devi imparare qualcosa che già diciamo di base sai va bene, cioè allora ti dicono già funziona bene o così questa, ti dicono cosa fai veramente che non ti interessa poi ho letto però non è tutto che c'è scritto magari adesso non mi ricordo più già come fa quando fai rendere in parte c'è quello di X poi Y poi fai e quello c'è
People, let's go back on track. Let's get a seat. Choo-choo. Final talk for the night, and then we're off for some Speck and beers. We honestly didn't expect this many people tonight.
Yeah, please go home. Speck&Tech is over. We had enough of this. This is the last time we ever did that. Take your seat.
Oh, puppy. Let's move on, people. The more time we spend now, the less time we have to enjoy the Speck and the beers. Time is ticking.
Con che autorità tagliendo la prima risponde?
Dino is ready? Okay, second talk for the night.
Vale, todos los Speck y el Tech está preparado por esta noche.
Okay, second talk for the night, finally. It's a long title, I cannot
Yeah,
even
it's
say
learning from biometrics to prevent cybersecurity threats.
And our speaker is Valerio Maggio, directly from FPK, but he will tell you everything. A big applause.
Big applause!
All right. Can you hear me? I think so. So, the title is going to be very practical, actually. This is learning for biometrics. I thought this could be interesting for you as a topic. That's going to be one application in machine learning. A little bit about myself. I'm actually a postdoc researcher in FPK. I'm in the MPBA unit. This is for predictive models for biomedicine and the environment. My background is in computer science. And I'm very interested in machine and deep learning in particular recently. So the core research we do is in biomedicine and the environment, but we also have lots of projects about the so-called applied machine learning, so typically what we call data science. In case you're interested, we're looking for students for internships or PhD thesis or thesis in general. So if you're interested, please tell me, that would be nice. Of course, I'm not going to talk about anything regarding the biomedicine things because it's not very funny stuff. So it's going to be applied machine learning. If you want to check out the website of the lab, is this one. A more, let's say, geeky part of me. That's me, I promise. I'm a fellow Pythonista, so I'm very involved into the Python community, European community and Italian community. I will tell you more about that by the end of this presentation. And you get one freebie if you get this one, anyway. So, let's get serious now. This talk is going to be a journey on what is typically a path you follow when you do data science. When you want to really work with data, with real data. Since I didn't know exactly the audience, I started with a very brief introduction on what machine learning is. How many of you already knows what machine learning is? So not all of you, I think. So I can introduce a little bit, a very basic concept. So I decided to do that by using clouds, words, and buzzwords, right? So we can analyze together what machine learning is. One cloud I found was this one. That the most important words you find in it is basically statistical, which is one aspect of machine learning. Basically, there's some math inside. Another interesting thing is algorithms, and this is very interesting because this means that it's not only math, it's basically something you really implement and you can make it working. Another important here word is data, of course, and the data is a very basic building block of everything. If you don't have any data, you cannot do anything in machine learning. And other words, just like complex, well, sometimes, clustering, behavior, results, well, this is very random words. Another one I found was this one. This probably was generated by collecting more theoretical stuff. This is about network Bayesian. This is again statistical stuff. Inference, deep learning is quite of a buzzword these days. Optimization, stochastic. So this is a little bit more theoretical stuff. Another one is this one, is deep learning. Deep learning, I tell you, is you can think of it as basically subsets of techniques. that are still machine learning. The very difference is in the machine learning technique you use to analyze the data. That's the only difference. So if you're using the so-called deep networks, so you're doing deep learning, otherwise you're doing machine learning. That's the difference. So finally, one cloud I found quite interesting is this one. It's very tiny, but data is the most important word. And that's because basically data is the very building block of machine learning. And the motto of machine learning is learning from data. And the reason why we want to learn from data is for future predictions. Machine learning actually comes in different flavors. You can talk about supervised learning, unsupervised learning, even reinforcement learning. I will tell you a little bit about these two here, because these are the two settings or flavors I'm going to explain in the practical example again. So what's the general path of a supervised setting for machine learning? What you have is basically the model here, so the machine learning algorithm. You start from here, the data. You always have the data that you want to turn into features, the so-called features, so the relevant information you think you want to use to learn from. And in this setting, the supervised setting, what you have is basically the labels, so that you can learn, you can use these labels as a reference for the model to learn from. So, and this path here, this flow of data, is called the training part. So you want to train your model here using these data, and finally you want to use the trained model for unseen data, also known as test data. Classical examples for supervised learning are classification. So in this case we want to classify images of handwritten digits, and we want the algorithm to understand automatically what's the number inside. So in this case the labels provided are categories, right? You get it? Another classical example is the house prices estimation. The very difference here is that the labels provided are not more categories, it's just real numbers. So you want to estimate, you have a series of data, the features, you have the prices of the houses you want to learn from, and then for new houses that you've never seen, you want the algorithm to exactly predict what the price is going to be. Right? This is the principal regression problem in machine learning in supervised setting. As for unsupervised, the very difference is in the fact that you do not provide to the algorithm any supervision. So this means that no label is provided in this setting, so that you want the algorithm to learn only from the data. You don't have any label to guide the learning. And one classical example is this one, is the clustering one. So you have all the data and you want to generate groups of data from the data itself, no labels provided. Another interesting thing here is about Python, and this is for a reason actually, because Python is nowadays the language of reference to do machine learning and deep learning in general. You can find plenty of tools in the ecosystem for both, let's say, machine learning and deep learning. I'm not going too much into details of this, but if you're interested, please ask me later on. So, in case you don't have any questions so far, I will go through the practical example. Feel free to interrupt me anyway. If you have a question or you have some doubts or nothing is clear, please tell me, it's fine. Okay? So, we want to try something concretely on the basis of what I said, but maybe, in case you're not into the field, you probably do not know where to start from. So I basically collected 5 steps that you can follow through to start with playing with machine learning. And I call it applied machine learning because it's basically what you typically do when you have some new data set and you want to try your fantastic model of machine learning you have in mind. So the very first step is, of course, is collect the data. That's mandatory. but that's basically step 0, I said. So the very first step, and this is the most important part, is look at the data and most of the time clean the data. When you start playing with machine learning, you use classical data sets you have. So apparently it seems very easy to play with data, but actually it's not. When you face real data, most of the time spent is in cleaning the data, because data never lies, but are typically dirty and you have to pre-process a lot of them. We have examples on the case I'm telling you tonight. After that, you have to prepare the data. I will tell you what this means. You have to train your model or your models, depending on how many ideas you have. And finally, you want to predict using the best model you get in the very first previous step, using unseen data. This is mandatory. So basically, you don't want to use the same data you use for training, because the very general aim or goal of machine learning is basically define algorithms that are able to generalize. So you want your algorithm to perform very well, even with data that the algorithm has never used during the training. And finally, you want to deploy your system in production, because we're talking about applied machine learning, so you want to really use this kind of things into pieces of software running somewhere. All right, so the problem we're going to talk about in this talk is identity fraud detection, which is somehow a part of the classification subset of problems. And the context, the background, is in cybersecurity. Two common frauds in this context are basically about account hijacking. So when people steal the account you have, so the fraudulent user has your credential to access your account, or car faking. We're not talking about car faking here, it's just about account hijacking. So the very problem here is how we identify the user to be exactly sure that the user who's accessing the system is the genuine user. There are plenty of things actually you can use. You can use biological biometrics, fingerprints, eyes or DNA, but there are also behavioral biometrics, and these are the ones we're going to use. So speech, for instance, voice, typing speed patterns, or the writing of a signature. More specifically, the biometric I'm going to use is the so-called keystroke dynamics. So basically, the keystroke dynamics is consistent in analyzing the way a user types on the keyboard, right? The general idea is that every single user has a unique fingerprint, considering the way each user types on the keyboard. So we can collect this data by calculating the time spent between one key press and one key release. We can talk about the dwell time and gap time. So dwell time is basically the time you spend pressing and releasing one key, and the gap time is the time you spend by passing from one key to another one. So the intuition I told you is basically this one. So each user can have a unique way to type on keyboard. So we want to leverage on the typing patterns to learn from the different users. So these are some details about the features we collected. So these features in literature are known as up time, dwell time, flight time, and down time. So these are series of, for instance, the up time is the time spent between releasing one key and releasing the next one. The dwell time is the time spent between pressing one and releasing the second one, so on and so forth, right? So all possible combination of pressing and releasing keys. So we have a series of timestamps. We collect these features, and we want to use these features to define one unique signatures for each user so that fraudulent users can be detected. More specifically, the settings of learning we're going to use is typically known as anomaly detection. So we want to identify anomalies. What we did was, so the very first step is, of course, data collection. We basically asked to 50 different users to type having the same user ID and password, manually, let's say, handcrafted to be a sort of complicated password. So each user has to type this for 10 times at least to complete one session. And in the very end, we collected almost more than 450 patterns for each user. And we have a collection of 50 different users. And the idea is basically to have one user to be the genuine one and the other 49 users to be the fraudulent one, because they have basically the same set of credentials. I remind you that this scenario we are moving into is basically one fraudulent user has stolen your credentials, so the system has to identify that the user who's going to access the system is not the genuine one. So step one, look at the data and clean them. These are some examples of data collected for a user. Something I forgot to mention is that we have two fields, username and password, and we are collecting data from web platforms and mobile platforms. So we have two different types of keywords. As you can see here, the data looks very differently from web and mobile here. So this is up time. So the up time for the username, but if you take a look at the password field, you have some sort of regularity in the data, so you cannot spot any real difference here between web and mobile. But as for the dwell time, which is a very different one, you can see very large difference. And so this gives you the idea that having different timing features may basically capture different patterns in the typing you want to leverage, and you want the algorithm to use to better understand which is the right user. And this is for password, and as you can see here, it's quite regular, especially on the web and mobile platform, more into the mobile one. If you look more carefully, you can actually spot some outliers. These kind of peaks here you find in the data. And these are genuine data. We are basically comparing data from the same user here. As you can see from the data, you can spot some outliers, so something which is wrong, and this is because data are dirty every time. We don't really know what happened here. It is because anything. Because the collection of the data went wrong, or because the user fell asleep. We don't know, right? So we basically always have dirty data, and we want to cope with them. So something we can do actually is to leverage on the unsupervised setting and to do some clustering of the data. So let's clusterize, for instance, the patterns in this session according to the shape they have, and we can spot some peak here. And so, for instance, we can say, okay, right, fine, we want to cut the data at this time so that every single peak I got above this one is not interesting for me. So we are cleaning the data here, so we are removing the outliers. Another thing you typically do is to scale the features, so you want to normalize the data, because we are going to play with a bunch of numbers, plenty of numbers. I want to scale them. We have actually plenty of strategies to normalize the data. Here you can see min-max scaling, standard scaling. So the idea is basically to normalize the data so that you can, it's typically for numerical reasons, because algorithms are going to crunch lots and lots of numbers, and you want to minimize the problem in errors in representation of numbers. and in the different scales of the features. So it's a very good practice to put all the data in the same scale. Once you've done that, you're not done yet, of course. You have to prepare the data, and what you do typically is this step, which is train test cut. What you typically do is you have the entire data set, and you want to split them in two different sets. The green one is the training data, so these are the data you're going to use in the training of the model, but not this one. So you put this data part, because these data are going to be used only in the prediction, right? So these will be the unseen data, so the data that the model will never see during the training. So you have the training data and the training labels. You train the model then. Once you've done here, you pass to the prediction step, you provide the test data, and you basically compare the prediction you provided with the model with the real labels, so with the expected data, and you basically evaluate the metrics. Is this clear? Right. What you really do is something a little bit more complicated. This process is called k-fold cross-validation. The idea is we are not splitting the data in two sets. We're actually splitting the data in three sets. We have training, validation, and test. The test is still the unseen data. So you put this, you take this data and you move it apart, and then you pass to the training step, the training and the validation set. The training data are used to train the model, and the validation is used to validate the model during the training. So you basically have some hints or clues on how the model is performing during the training. So you train the model, and once you're during the training, you're using this validation data to evaluate the metric, and so you can see if the model is actually learning something or not. All right? And this cross-validation technique is basically a sort of trick that you get the training data, you divide that into, for instance, 5-fold. So in a number of folds, this is why we train. So in this case, it's 5-fold. So we divided the training data into 5-fold. 1 fold is for validation, the other fold is for training, and you repeat these, alternating the folds you use in the validation step, right? It's just a trick to basically have all the data in the training and in validation. Right, once you're there, you have your model, right? So imagine that you have your model, you want to train and test a machine learning model. And this is what we basically did. I'm not going very much into the details, but if you're interested, please ask me later on. So the solution we implemented was this one. It was based on a couple of two different models of so-called deep models, deep learning. The very first one is the so-called autoencoder. This is pretty interesting, actually. This is unsupervised setting. So the general idea is I want to build a model that is able to get some genuine pattern in input, and the output of this model is to basically reconstruct the original pattern. So this network is going to learn from the genuine user, right? So I do basically train this model from the set of genuine patterns, and the output of this model is to learn exactly the same pattern. The best this model is performing, the best this model is reconstructing the original pattern. And the second step is using this autoencoder in combination of a sort of discriminator network. So the idea is that I use this autoencoder that has been trained on genuine pattern. So if I provide new genuine patterns here, the reconstruction should be correct. If I provide fraudulent patterns, since they're supposed to be different, the reconstruction here should be very worse, because it should be different. So the idea is that using the reconstruction strategies here, put these in a discriminator network that is trained on genuine and adversarial patterns, so fraudulent patterns.
so that these networks can learn from correct ones and wrong ones. And this is the general idea. So how do we know if this idea works? We have some metrics. The first one is the false acceptance rate. So it's basically the so-called false false positive rate. So the percentage of user falsely accepted. So the number of fraudulent user recognized as genuine one. The false rejection rate is the opposite. So the number of genuine user recognized as fraudulent ones. And finally, we have the equal error rate, which is basically how we do in the overall. So in the general accuracy we have. And so these are the results we got. So it performed quite good. It was 5,200 samples in the test set. The error rate is this one. So the error rate is 0.003. So it's very accurate, this one. And especially here, the false acceptance rate and the false rejection rate is very low. These two metrics are the most important ones. It's not important how many users you detect, but it's also important how many users you correctly do not deny the service. There's another sample size test. This is basically details. So the general idea was, how many patterns do we need to be confident about the accuracy of the model? So we selected 3 users, new ones, completely new. We trained the model using different sizes of samples every time during the training, from 100 up to 10. And we analyzed what was the performance of the model using only 10 repetitions, which is quite a few samples. And it indeed was basically good, depending on the user, basically. This is very user dependent, because we have one model for each user, and for these users worked quite good, actually, no errors here. But it really depends on the same metric here for different users. Finally, basically, this is just an analysis of what was the importance of the different features we used. It's not very interesting here. It's not very readable here. But something popped up is that typically the central features were the most important ones. I mean, the timing used in the very middle of the username and password. That was quite interesting. Right, so very quickly, the last step was deploying your solution. So this is going to be a little more technical. This is not really about machine learning, it's just how you deploy your model into production. We basically built this logical architecture, and this logical architecture was mapped onto a set of RESTful APIs. Do you know what RESTful API is? Right? So we basically store all the data into the MongoDB database, which is a non-structured database. This database was the main trigger to run the different processing. So once we got the data from the user, we extracted the features, and then we passed those features to the learning so that we can generate the predictions. So we called it the API engine. On top of it, we built the model of learning, so the deep learning model and the feature extraction from the login of the user. And everything was stored into the MongoDB database. And all the solution was deployed as a series of Docker images, just because you want to move this service from one machine to a different one, depending on the way you want to deploy the machine. I'm not saying anything more about that. If you're interested, please ask me later on. So actually, this is what I was, what I wanted you to talk about. I hope this was interesting for you. I had some shameless plug at the very end. I'm very much involved into the organization of PyData conference. Actually, PyData Florence is the major conference for Python and data in Italy. If you're interested, pydata.it is the reference. This time we're going to be again in Florence on the one weekend of April. And we are host as PyData Florence in PyCon9, which is the national conference for Python. Actually, Speck&Tech is going to be our media partner. As media partner, they will be eligible for 2 free tickets. Actually, the conference is quite cheap anyway. Woo! Yeah. We're saying this. Anyway, so yeah, it's cheap. It's very cheap anyway. They're going to tell you what's going to be the way you can get these 2 tickets. So if you're interested, please check out pycon.it. Actually, you can find some flyers, and me and some other guys here from the organization are here tonight. So if you're interested, we can talk about that later on. This is going to be Python in Italy. What about Python in Trento? Actually, Python in Trento is going to be lots of fun. We're going to have Eurosci Pi this year in Trento. Eurosci Pi is going to be last week of August. Eurosci Pi is the international conference about scientific Python. So this is very much about these kind of things, using Python. These are the tentative dates. We're going to finalize them very soon. It will be here in Trento, in the very center. So be post on eurosci.org on Twitter anyway. And finally, we also have trento.python.it, which is the meetup Python we do. The next meetup will be on February the 22nd at C-Lab. Sorry. And so actually be posted on all the social media accounts we have. And last but not least, shameless self-promotion. If you're interested and you want to have some more technical details about that, there's a repository of mine on my GitHub page, which is deep learning using Keras and TensorFlow, quite popular one. Actually, when I did the slide, it was almost 1,800 stars here in my GitHub, but exactly a few seconds ago, I found out that it was 1,800. So thank you very much. That's it, and enjoy the beer.
Yeah, thank you very much for the gifts, mostly. It was the past I understood the most. And, no, I'm not joking. It was very interesting, so I'm sure you have plenty of questions, so feel free to ask.
How much time did you spend?
Oh, sorry?
How much time did you spend on creating the system and deploying it?
I thought of
Well, it
gifts.
really depends on how cool you are.
No,
I mean, I'm very cool, so I...
If you got how many stars on GitHub,
No,
yeah?
I'm kidding. Actually, the most difficult part was about cleaning the data. Basically, the idea comes with practicing most of the time. So, I don't know. I can... The project lasts 3-4 months. Yes, that was it. Especially because we previously had to collect the data from users.
We said it already, but if you're interested in slides, they will be on our website very soon, I guess. So yeah, you don't have to take screenshots or notes on everything, and I'm gonna go for our second question.
Is there some kind of learning algorithm that keeps learning after being deployed on the data you get feed off of?
Yeah, that's a good question, actually. This system was deployed, probably you can spot from the architecture with it, or Probably not. Yes. So the general idea was that in this particular context, the user may change its habits. So the user may change the device, the user may change the way he or she types on the keyboard. So in this particular context, the question is very important because you cannot rely on the original patterns you have. So the idea we come up with was to implement a retraining process. So every once in a while, so depending on the deployment settings you want. For instance, you want to retrain the model on new data once a month, for instance, or when you collected some, let's say, 50 or 100 new samples, and so you want the model to be retrained, to be basically refined on the new patterns you can get. So once you got a trained model, you can always keep on training it if you want to refine it. There is an additional, it's actually a very specific setting of learning, which is called online learning, which is basically something a little bit different from what I told you. So you don't have the training and the test as two separate processes. You keep on training the models once you get the new data. This is, for instance, something which is supposed to be running online. So you have one model running every time online. And so once you get new data, you keep on training the model. And of course, you hopefully improve the performances or not, depending on the bit you have.
So you're using a generative adversarial network kind of approach, right?
Nope.
No? What's about the adversarial part?
Yeah, that was a trick. Okay. No, kidding. Actually, it was adversarial in the sense that it was a binary classification problem. Okay. I didn't use any gun because we're not generating anything. We're just using true data collected from all the users. Actually, we have plenty of them. In the very end, the training set was 26,000 samples, so it was huge. So I don't really need to generate new ones. But in any way, using guns can be an interesting problem to generate forged, to make the model more robust.
Okay, thank you. So which kind of neural network you used for discriminative part?
It was just a classifier, fully connected.
Recurrent neural network?
No, no, because I didn't have any. I don't use any time dependency. It was just fully connected. Okay, just a classifier. Thank you. Just fully connected. In case you're wondering, basically the GANs networks are these very cool ideas of having these couple of networks working together. You have basically two models. One is in charge of detecting what is real data and what is fake data, and this is the discriminator, and the generator, the second network, is working against the discriminator, trying to learn how to fake the discriminator. So this is very interesting. This is called adversarial basically because they are learning against one opposite the other. So it's quite cool. I can go on the all night if you want.
Yeah. I guess we can go on the all night on beers anyway, but fine.
On the application side, what does the rejection trigger? Multi-factor authentication or just rejection?
No, you mean what was the trigger for triggering all the process in the authentication step?
No, when you use the application on real real stuff, when you detect maybe fake user, what do you do?
All right, that's a good question. Actually, it was just alarming. It was just rising alarms because there was this security operating center, I guess, SOC. These are basically people in charge of analyzing any alarms they get from the security systems. And so this model was supposed to be a sort of aiding system to reduce the number of alarms you get, to reduce the false alarms, basically. But in any way, this is not any denial of service. So in case, for instance, a fraudulent user was accessing the account, or the genuine one was denied from accessing, according to the model, no denial of service were really implemented. So it was just raising an alarm to be checked.
Because I was thinking maybe injuries or something can disturb the user on a consistent basis.
No,
So
actually no.
In this case, no.
In this case, no, and even the data collection is no, is totally not affecting the user experience.
Okay.
This is why you want to collect keystroke patterns. It's one of the reasons why they're quite largely used to these kind of things.
Okay, thank you.
They're not intrusive, let's say.
Cool, very final question. Okay.
During the training tests, did you focus on try to minimize false positives and false negatives equally, or one was more important than the other?
Do you mean in this splitting?
Yeah.
When I split the data, you mean?
There was a table of false negatives and false positives.
Mm-hmm. This one, you mean?
Yeah. Yes. The false rejection rate was more important than the other.
These strongly depends on the. In my case, no, they were equally important, but it strongly depends on the deployment setting. So when you go to the client, for instance, let's say banking system, and depending on the way they want to deploy this kind of techniques, these may vary actually. And this is the typical balance you want to get from. I want to when you search something on Google, you can say I want Google to be very precise in what I'm looking for, or I want Google to return everything which is inherent on what I'm looking for, and then it's up to me. That's the typical balance.
Any more questions?
Yes.
How you got this British accent?
Sorry? I would try to talk with like your kind of accent. No, I'm joking. Regarding the I'm not able to. Regarding the training part, you gave us an example of like asking the user to input the account and password. Was that the actual example? And if so, do you plan to extend it like to mouse movements or other stuff? Do you have any example of that? Is that useful in any kind of?
Well, actually, sorry, I start from the last question. Yeah. Using mouse gestures was the idea of the follow-up of these projects, but totally was not accepted, so we cannot do that. But anyway, that's definitely interesting. You can actually mix and try to combine different modalities of data, so you want to learn from both of them, and then you can decide which feature, let's say, of information is more important than the other one. You can actually let the algorithm to figure these out automatically. The first question is, we asked the 50 users to type the same password only because we can have genuine and fraudulent ones. So it was just a trick to have negative and positive samples. In real case, of course, you have users having different passwords. And this is the reason why we basically trained one single machine learning model for one single user. So in case your system has 500 users, you're going to have 500 different learning models trained.
Cool, that was it, I would say. Another big applause to our speaker. And if you're interested, we'll follow up on the coming days on our social media.
Before wrapping up, I'm moving to the most important thing, which is Speck. I mean, regarding, of course, to machine learning anyway. Yeah, we need to move a bit of stuff around the room, and you can definitely help us. Some of you have a degree, some don't, but still, like you're approaching, some of you have a diploma, which should be enough to stack chairs.
Stay strong diplomas.
Yeah. So yeah, just get your chairs, especially the orange and the black ones can go together. You can pull them here on this side of the room. Also the green one, just try to move all the stuff here because we will actually have a fuckload of Speck and plenty of beers for all the rest of the night. We say goodbye to everyone on our live on Facebook, and especially a big thank you to everyone for being here and to all the people that are helping us to make Speck&Tech great again.
Yeah, and a preview, if you want a ticket for PyCon 9, you need to run naked with Speck&Tech tattooed on your chest. That is the first question. Please remind it.